I'm doing a little video. I'm going to take a clip out of Bob the Pseudoscience Guy's video, do a little commentary where he's discussing the radius of the Earth. He's about to talk about the black swan that everybody knows about in this argument. And it's quite interesting what he says.
To see it on the beach. 6 feet. Now, the reason that I thought about this was that many of us in the debunking community have had a look at flat Earth videos that claim they quote unquote see too far, therefore the Earth is flat. What?
There are literally hundreds of videos where we see too far according to their radius.
Well, let's have a look at that claim. Now, when we see too far, is that truly a proof of the Earth being flat? No, it's not.
Remember what he just said. Just because we see further doesn't mean the Earth is flat. But there's a little but to this.
Means that we have a different radius.
Oh, did he just say that? It means we have a different radius. I wonder what the implications of a different radius would be.
Because even without using the known radius of the Earth, simply by knowing the distance to the object and how much of that object we can see from the beach, we can calculate what the radius of the Earth is. Because one of the things flat Earth loves to do is they don't observe things from mountains. They observe things from a foot off the surface of the water. And they do that to take maximum advantage of refraction. But
there's no refraction. That's just a bunch of crap that the Globies have had to make up to try to explain away why we see too far. They say that things beyond the curve are refracted upwards. It's just total hogwash. And I think Bob even knows. I don't know how he says this with a straight face, but let's go on.
Does that prove that the Earth is flat? Or does that just change the radius? Let's have a look at a classic example.
That's a big problem for your model if it changes the radius.
Well, have we ever seen this picture before? Let's have a look at something here. First of all, the observer height, 1 foot. They're making a real big deal out of that. However, they also give the distance to platform habitat at 9.41 miles. So we have D. Now the question is, what's the lowest point on this oil rig that we can see? Obviously, there's tremendous distortion due to refraction. But let's look down at the bottom.
The distortion is just because of atmospheric effects, not refraction.
Bottom here. Here's the bottom of the rig. These are cross members. And then there looks like there's a solid object right down here by the horizon. Let's go see if we can identify any of these.
Well, this so-called solid object looks pretty much similar to the base at the other one that's closer. Now, he's going to say there's 20 feet missing here in just a second. But obviously, you can see the horizon extends far beyond that. The platform in the distance, the one on the left. That's just the distance. That 9.41 miles is just the distance to the platform. But all it is compression. It's not missing anything. And you know that because you can see the horizon beyond it. It's just compressed. The whole platform is compressed compared to the one on the right because it's much further. It's over 3 miles further.
Parts. So, here is platform habitat. Here is the bottom of the rig. Here are these areas where these crossbars are, and you can see those here. And then down here you can see a boat launch, but I don't see it anywhere here. I don't see this pipeline coming out. That seems to be below what I'm looking at. The only thing, the lowest object that I can clearly identify looks like it's going to be the bottom of this cross-hatched area where these cross members are. I don't see anything down here. Now, another thing that I see is there's a watermark right there. There are watermarks here. This is all rusted. There are watermarks here.
So now, Dingling Bob is going to tell you should see watermarks on those supports on the one on the left here. That's ridiculous. At that distance, you're never going to identify a watermark. What a joke.
There are watermarks out in this area. So that looks like it's the high water mark. This is obviously low tide. Let's go ahead and have a look at the permit documents for platform habitat. Now, this is rather interesting. Here is the water. Up to that boat landing, it's 15 feet above the water. And up to this area, it's looking like it's approximately 40 feet in elevation. The platform itself is 17 feet above that. So let's go back to this other photo right here. So it says that this is 40 feet above the water. Now we can calculate that out because a standard door is about 80 inches. Now it says that this thickness right here is 17 feet. And then it says from there,
you're not even going to identify a door at that distance. Everything is compressed.
There, it's down, looks like another 27 feet to the water level. We probably have about 20 feet of this platform missing. Let's be generous with that. It could.
There's nothing missing. The horizon is further up in the frame in the distance, easily seen on this picture. There's nothing missing. It's all compressed. When everything's compressed, it causes a Rayleigh criterion effects when you pass the limit of the Rayleigh criterion, where all kinds of detail is unresolvable.
Be a little bit more. The curve calculator says it ought to be about 45 feet, but as I said, we've got a tremendous amount of distortion here. And I'm saying that we're missing about 20 feet of this platform. So let's go ahead and see what we have. Okay, so the distance is going to be 9.41 miles, which is what's listed on the Flat Earth video, equals 49,685 feet, roughly. Okay? The height that we're missing is 20 feet.
Once again, there's no height missing. It's compressed. You can see the horizon further up the frame of the picture and further out.
That's D. So let's go ahead and plug it in, see what the radius of the Earth is. So,
this is about to be hilarious, and he seems perfectly okay with it.
49,685.
Remember, this is his best case scenario, and he's taking and adding the 20 feet into that, his calculations, which isn't missing, it's just compressed. But let's just give it to him. Doesn't matter. He's still screwed.
Squared minus 20 squared over 40. That will be our radius of the Earth. So let's go ahead and see what we have. Well, there we go. That gives us a radius of the Earth And it's obviously really high because of all the distortion.
Bob.
But it's only 11,688.4 miles.
Which would give you
That's about 3 times the actual radius of the Earth.
Miles,
and
Bob.
It's about 1/3 the radius of Jupiter, which is over 45.
Why is he even bringing Jupiter up in this? He just gave you a radius that will give you the equivalent of almost 37,000 miles at the equator.
5,000 miles. So, what did they prove with their black swan? The only thing that they can actually claim is that they demonstrated there's a possibility that the Earth is a sphere about 3 times larger.
The only thing they can claim, he can't show otherwise, that he included is 20 feet of missing, so-called missing platform. It would have been even worse if he hadn't put that in there. But go on, Bob.
Than we think it is. Now, Quantum Eraser and the others have put out claims that this means that there's a radius of 250,000 miles. Well, we just calculated it. It's less than 12,000 miles. It's big, but it's still a sphere. So,
it's big, but it's still a sphere. That's hilarious. So, there are so many implications of a circumference of 37,000 miles at the equator that just blows their globe model, their current model, out of the water. It's dead.
This is Bob the Science Guy signing out from Northern Michigan.
He should change his name to Bob the Pseudoscience Guy. It'd be more fitting.
Thank you very much for stopping by, and I hope that this method comes in useful, because you can use it in all sorts of these low-angle observations that they make where they claim that they see too far. Stay well, folks.
There's nothing wrong with a low-angle observation. Well, thanks to Bob, we now see that there's a complete possibility that there is indeed a much larger Earth. He's going to say it doesn't matter, it's still round. But it does matter. And it doesn't make it round, it doesn't make it flat. That's true. But at the same time, if it's round and it's got a circumference that's far bigger, he's got a problem. Thanks, Bob.